TCP IP services. Now you see, throughout the day, we started with very broad, big picture, very broader perspective. Then we get inside the definitions and details. And last session was also on TCP IP. This session is also. That means we are going step by step. In this session, IP address assignment methods, host name resolution, NetBIOS name resolution, TCP IP utilities, TCP IP services, IPv6 or IPv6 that is IP version 6 protocol. All these topics will be discussed. Methods of assigning IP addresses. There are various methods which we use to assign the IP address to the machines or the devices. The address assignment include assigning an IP address, a default gateway, one or more domain name servers that resolve names to IP addresses, time servers, and so forth. Before selecting the desired IP address assignment method, these questions should be answered because these will decide what method will be best for your requirement. How many devices need the IP address? Remember, IP address is the primary way to identify devices on network. When you type oracle.com, this is domain. .com is top level domain. There is a server which works for you to give the corresponding IP address of oracle.com when you type oracle.com in the browser, and that server is domain name server. So how many IP addresses means how many devices you are planning to connect? You need to answer this question. Based on that, you will adopt the method. Which devices require static IP address assignment? There might be certain devices which which definitely you would want to keep the same IP address. Is IP address renumbering expected in future? Is the administrator required to track devices and their IP addresses? Do additional parameters like default gateway name servers have to be configured? Are there any availability issues? Are there any security issues? You need to answer these questions before you plan what should be the best IP address method, IP address assignment method for you in your scenario. Static versus dynamic IP address assignment method. As you notice, this was discussed in the previous session also, but this time it will be in little more detail. Static. An IP address is statically assigned to a system. The network administrator configures the IP address, default gateway, and name servers manually by entering them into a special file or files on the end system with either graphical or text interface. These special files are basically configuration files corresponding to the interface, network interface card. Maybe physical network interface card or virtual, depending on whether you are talking about a physical machine or you are talking about a virtual machine. Dynamic IP addresses. IP addresses are dynamically assigned to end systems. The administrator must set up a server to assign the addresses. Examples of available address assignment protocols include reverse address resolution protocol, boot protocol, DHCP. DHCP is the newest and provides the most features. The best example near you at your place where you are sitting right now, there is a DHCP server running. Where is that server in your environment? The router, the switch which you are using to connect to your laptop with the internet. Because you may be having mobile phone, multiple laptops or multiple mobile name using the same Wi-Fi connection. So the Wi-Fi router has a DHCP server, and that DHCP server is giving IP addresses to each of the device. Remember, every device has to have IP address. Without that, it is impossible to communicate. It is impossible to connect. Therefore, that DHCP server on the router on the switch will assign the IP address to your mobile or mobiles and the laptops or desktops. And then they will be able to connect with each other, talk to each other, or connect to the internet. But that is the static IP. I mean, individual local IP, not static, local IP, dynamic IP, but local IP. From the internet service provider, you also get one IP address which is assigned to the router itself, and that is dynamic IP, which is basically assigned by the service provider and which is public IP. Public IP address means that is unique in the world. You can check that IP on your system also if you check whatismyip.com. You can simply go and check what is my IP. That IP address will be unique, and this IP address will be same for everybody, all devices, because that is given to the service provider. So whether you are using Oracle VM VirtualBox or the router, there are so many options available, but dynamic IP address is given by the DHCP server. So Oracle VirtualBox also have the DHCP server enabled, and every machine we create in the Oracle VirtualBox will get a dynamic IP address if you don't assign one with the static method. The domain name system, the DNS server. DNS server is international, or you can say internet scoped or big picture of the server, which helps you in resolving the names or domain names into IP addresses. So domain name system is usually used to translate a host name or domain name into an IP address. Domain names comprise a hierarchy so that names are unique yet easy to remember. That hierarchy start from dot, that is top level. So dot means the root domain, that is root domain. I remember earlier when I started working and the internet was introduced, I recollect that there were earlier 9 top level domains, that is .com, edu, org, and so on. So there were 9 TLDs. Dot was root, .com, so we actually write it at .org dot. So we start from this direction. So this end dot indicate the root. So or .com dot. So we used to call them as top level domains. We still call them. We have a lot of top level domains. Then under top level domains, we used to define our own domains like Oracle. So that is called domain. So oracle.com dot, that will be the fully qualified domain name of this. So under this dot is root, com is top level, and then Oracle is your domain. So fully qualified domain will become oracle.com dot. That is the hierarchical representation. So this DNS server helps in managing and resolving these domain names into corresponding IP addresses. And remember, they are universally unique. This is actually, they store the data of these domains and the corresponding IP addresses in files called zone files. Every domain name system server is responsible, is authoritative or authorized for specific zones where we create the domains and their IP addresses. That's how the DNS server works. The DNS server characteristics define the request for comment RFC 1034 and RFC 1035. DNS defines a hierarchical namespace for computer networks, a service for resolving names into IP addresses. DNS namespace, as I said, on the top we have top level domain like com is called TLD. Root is not mentioned here, which is dot. Then it becomes Microsoft.com. This is a top level domain or domain name, and then his subdomain. So sales.microsoft, msn.microsoft, mis.microsoft, these are all namespaces, subdomains. A DNS name resolution process on your system, you ask for a client. Let's say you type in the browser google.com. The request goes through your internet service provider through the router. The internet service provider will have its own cache, temporary storage of domain names and the IP addresses. If there is a cache and the details are available, it will respond from the cache itself. If no, then it will forward the request to next available server. So the local DNS, this is your internet service provider server, ISP. Then if it is not found here, then the request will be sent to root name server. So there are multiple root name servers. Someone should respond that yes, I am authoritative for this domain and this domain has the IP address this, because ultimately the objective is to get the IP address from the domain name. So this is the process of resolving the IP addresses into domain name or domain name into IP addresses. DNS record types. I was talking about the zone file. When we create a DNS server, we create configuration file and the zone file. The zone file is nothing but the database that defines what all domains and subdomains and corresponding IP addresses and canonical names and text and all are available in this zone. We call them, each one of them is known as record. What are the different type of records we can create in a zone file? To specify, to indicate, to convey the message, okay, this record specify these details. Like first, we always start with start of authority, that is SOA record. This indicates that the name server is authoritative source for the domain. Then we specify name server or NS. This identifies the DNS server in the domain. Then address is A, which contains the name to address mapping of computer in a domain, means the domain and the IP address. Then we have canonical name, C name. It creates an alternative or alias name for a computer already represented by an address record. Pointer is PTR, contains an address to name mapping in address ARPA for a computer in the domain. And then similarly, we have mail exchanger MX. This identifies the computer that is responsible for processing email traffic addressed to the domain. There are other records also, like text records, then other records. There are a lot of record types available for DNS server. DNS client is called a resolver, or which is looking for the corresponding IP address for a given domain. A call to get host by name is handled by a resolver, typically part of the client. Most Unix workstations have the file etcresolve.com. This file is very crucial, and the simplest proof of this file is if you start virtual machine or Oracle VPN and internet is not working in the virtual machine because of the VPN connectivity because we are connected to VPN, Oracle VPN. Then what we suggest always is we delete this file, disconnect from Oracle VPN, and then restart the server. When we do that, this file will be automatically recreated, because this file contains the local domain and the addresses of DNS server for that domain, which generally, if we are using Oracle cloud, Oracle VPN, you will have a different proxy settings, and the DNS server will be different, which may not allow you to connect to the internet. So this is typically a solution which I recommend in my training, that are you connected to Oracle VPN? Yes, I was connected. So internet is not working in the virtual machine. No, it is not working. So I simply recommend go and delete this file and then restart the network service. It will start working. That's what we usually get. So typical entries in this file are like this: domain, then IP addresses. So these are the entries of this file in this format. NSLOOKUP. NSLOOKUP is an interactive resolver that allows the user to communicate directly to a DNS server. It's usually available on Unix workstations only. NetBIOS and NetBEUI. NetBIOS basic, that is Network Basic Input Output System, is a protocol originally designed for IBM to provide transport and session layer services for applications running on small homogeneous network. NetBEUI can support only 254 connections, however does not allow for good security because NetBEUI frames include only data link layer or MAC addresses and not network layer addresses, so it is not routable. Windows Internet Naming Service (WINS). It provides a means for resolving NetBIOS names to IP addresses. A computer's NetBIOS name and its TCP/IP hostname are different entities, though you can have the same name for both. WINS has the same relationship to NetBIOS as DNS has to TCP/IP, that is resolving. So WINS does not assign names or IP addresses, but merely keep track of which NetBIOS names are linked to which IP addresses. WINS is now obsolete. It is replaced by DNS only. Ping is a command. It's supplied with virtually every TCP/IP implementation. It tests connectivity to other TCP/IP systems. Quite simple syntax: ping followed by the domain name or the IP address. Traceroute, IPCONFIG.EXE, ARP.EXE, these are commands on Windows which we use, or the utilities in Windows. Traceroute is a variant of ping command. It displays a list of routers on the path that packet take to a destination. It uses echo request and echo reply messages as ping command does. It modifies the time to live, that is TTL value, in each successive echo request message. Can be used to troubleshoot network communications problems by specifying the location of the difficulty. IPCONFIG.EXE is Windows utility that displays TCP/IP configuration parameters. Then we also have ARP.EXE that enables you to view and modify contents of ARP cache. Adding addresses to ARP cache speed up the connection process, and addresses added manually to ARP caches are not purged, not deleted. Using ARP.EXE, syntax is ARP-A IP address -N IP tables, IP address -S IP address, hardware address interface, and D is IP address and interface, that is destination. A stands for address, display the content of specific ARP cache entry. N display the content of ARP cache for a network interface. S new entry for ARP cache, and D for delete an entry in the ARP cache. These are the commands which we used. Using NETSTAT is available on Windows and Linux both. It's a very good command for monitoring. NetStat interval -a protocol -n-e-r-s. Interval refers the display every interval seconds what you specify. -a display the current network connections and the port that are currently listening for incoming network connections. -p followed by protocol, it display current active connections for the protocol specified by protocol variable. -n causes the program to identify computers using IP addresses instead of names. -e displays the incoming and outgoing traffic statistics for network interface. -r displays the routing table plus the current active connections. -s a detailed network statistics for IP address, that is Internet Control Message Protocol, ICMP, TCP, User Datagram Protocol, and all. This is NetStat. So therefore, if you carefully go through once more, you will see that yes, NetStat is quite comprehensive command to monitor the network. Then we have NBStat, NBTstat, -a name, -a IP address, CNRRS, multiple options are there. A is the name, display the NetBIOS names registered on the computer identified by the name variable, what you specify. Uppercase A followed by IP address, it displays the IP address, that is NetBIOS names registered on the computer identified by IP address variable. Small c, it displays the content of local computer NetBIOS name cache. -n, NetBIOS names registered on the local computer, and -r displays the number of NetBIOS names registered and resolved by local computer using both broadcast and wins. This is NBStat. Then we have NSLOOKUP. NSLOOKUP will simply go and fetch the IP address if it is available. So you specify the DNS name. DNS lookup, DNS name, DNS server. This is the syntax. DNS name specify the DNS name you want to resolve, and DNS server specify the DNS name or IP address of the DNS server that you want to query for the name specified in the DNS name variable. NSLOOKUP command. Then we also have a utility called Telnet, very good utility. Though it is insecure, therefore it is used only for local connection tracking or local monitoring or local service verification purpose, because the data transferred with the Telnet by Telnet is transferred in plain text format. IP address, passwords and usernames all will be in plain text format, which is insecure, so you can't use it for remote connectivity, though it was meant earlier for remote connectivity only. It provides remote control capabilities. Telnet client can execute command on the server and view the results. Telnet was designed for Unix systems. All Windows versions include a Telnet client. Windows 2000 and later version have Telnet server facility also. Then RARP Communications. Basically that's called broadcast, hardware address broadcast. So you broadcast, hardware address broadcast, hardware address broadcast, hardware address broadcast. But then the server will respond who can afford an IP address and IP address unicast. So this RARP server will give the IP address, unicast IP address to the machine. This client will send a request to everybody nearby. Is there anybody who can give me IP address? This is how RARP works. So it will broadcast the hardware address. The RARP server will give the IP address to this hardware. BOOTP, it supplies an IP address and other transmission control protocol internet parameters. Can supply an executable boot file using TFTP, that is trivial file system file transfer protocol. This line is actually indicating that how can we have a remote boot enabled. And let me tell you, I use this method to automatically install Linux on 15, 20 or 30 computers in just 1 hour flat. How I achieve that? I simply put dump of Linux on one machine. I make that machine bootable and I create a TFTP server, configure a TFTP server on that machine, a DHCP server on that machine, and auto installation file, that is we call it as what is that file called? I'm forgetting the name, which is actually is nothing but answer of all the questions which you supply during the installation process of Kickstart. Oh, the file name is Kickstart file. So we create a Kickstart file that has got answer of all the questions which are asked during the installation time. So we specify the Kickstart file, we specify the boot image, we specify the DHCP server, we configure this machine with all these details. Now what happens is when a remote machine connects to this machine, which is blank raw machine, the first thing is you just need to connect internet cable. So this is the basic thing, that when you start the machine will try to get the IP address. It will send a request for IP address. All right. That request DHCP server will respond, will give the IP address to the machine. Then it will try to search for operating system, which can be supplied using the auto installation concept, which is Kickstart file I'm talking about, and the TFTP server where the dump is lying. So this BOOTP and TFTP server is great mechanism where we do automated installation of Linux machine. It requires you to manually reconfigure parameters for each client, cannot allocate IP addresses automatically, cannot prevent IP address duplication. This is BOOTP problems. DHCP is what we specify, as I said. Addresses the shortcomings of RARP and BOOTP, dynamically allocate IP addresses from a pool, reclaim unused addresses. It prevents IP address duplication and supplies all TCP IP parameters. The components of DHCP server are client, server, and protocol. So assignment process is the client send a request, that is we call it as DHCP discover request. The server is monitoring that any request coming in. So server will respond with a DHCP offer. The client will accept this offer and it will say DHCP request. DHCP server will send the acknowledgement that okay, great, you got the IP address and this is your IP address. That's a sequence of steps how the addresses are assigned by the DHCP server to the client. The host file, it is actually available in Windows search system also, Linux also. On Linux machine the file is available under /etc folder. It is a host file, is a lookup file. It is actually a lookup table, or also we can also call it as local resolver. This is good example, good simplified process if you want a small set of computers in your local area network to communicate with each other with host name without IP address. This can be done using this etc host file. Only problem, only constraint is that same etc host file should be available on all the nodes, all the machines which needs to be connected and which needs to talk. So a host file is a lookup table containing the list of host names and their equivalent IP addresses. Each computer has its own host file. As the internet grew, the host file became impractical and the domain name system eventually replaced it. But as I said, domain name system is for internet, and yes, host file is meaningless, useless, will not serve any purpose. But local area network, we still prefer and we still use this host file. Introduction to IPv6. While most networks are configured with IPv4, several regions have run out of public IPv4 addresses. Internet Protocol version 6 IPv6 was introduced in late 1990s as a replacement for IPv4. It turns out that 4,232,000,000 IPv4 addresses are not enough. IPv6 supports many more addresses, potentially up to 3.4 raised to the power 10 raised to the power 1038. That is 340 undecillion addresses. Basic IPv4 addressing. IPv4 addresses are made up of 128 bits and are set up in hexadecimal notation, also known as base. 0, 1, 2, 3, 4 up to A, B, C, D, E, F. This is hexadecimal number because hexadecimal number system has 16 bits, 0 to 9 and A to F. An IPv6 address is normally organized in 8 groups of 4 hexadecimal numbers called nibbles in this format. First nibble, second nibble, third, fourth, and these are all nibbles. To simplify IPv4 addressing further, remove any leading zeros in a nibble. For example, you can write 0db8 as db8, 0072 as 72, and so on and so forth. Further, if you have a sequence of 0000 nibble with a pair of colons, so you can replace a sequence of 4 zeros nibbles with a pair of colons. For example, you can abbreviate this 0000 colon 0000 colon 0000 with a pair of colons, because you can ignore this and you can simply write colon colon. That's it. You don't need the others. The compact form of IPv6 addresses, there's a typo here, it is form, FORM. Hence we can rewrite the previous address in much more compact form, 2011 db8 3dab 1 and colon colon 72. Go and recollect that, because here we have 0000, so we can write all of them with 2 colon, and this 0001 can be simply written as 1. So this will be the simple IPv6 address. Similarly to IPv4, IPv6 addresses are made up of 2 parts, the host and the network address. The host portion of IPv6 address is known as interface identifier. In IPv6, subnet masks are typically supplied with a prefix notation such as /48. Assuming that IPv6 addresses this 2001 db8 3dab 172 has a network prefix of /64. In this case, that network prefix is this. The interface identifier includes the last 64 bits shown as hexadecimal number 72. That's all for this session. Thank you very much.